Hi folks, welcome back. So, in the previous, set of videos, we have talked about gateway APIs and then, how we can, leverage the features of different gateway classes and then, eventually via, the gateways and HTTP routes, how we can expose a particular microservice that is with and without certificate, everything. So now it's time for us to enter into another topic, which is like MCS, which popularly called as an MCS, which is expands as multi-cluster service, and and an MCG, which is like multi-cluster gateway. So these two are like comes hand in hand. It's one of the best features you can say. So now the question is, what is this MCS and why do we need? So let's take a scenario, usually in a particular Kubernetes cluster, you will have a set of microservices, which are isolated in different namespaces. Say, for example, namespace A, namespace B, and namespace C. Similarly, another Kubernetes cluster where you have, a different set of namespaces like test, dev, prod, and all. They are, two different Kubernetes service. However, there is a one particular, service or particular microservice which is required, or it's a common for both the clusters. So usually what happens in a typical scenario, the individuals will go and deploy that applications in a cluster A and they'll expose it in a particular service. And similarly, they'll deploy that application in cluster B and they'll deploy it in a cluster. I mean, they expose it to a particular service as well. That's a typical usual setup or a generic setup, I can say. Now the question is, why do I need to deploy this in two different when I can have that feature of leveraging this service by deploying it only on one cluster and consuming it in another cluster? Can I do that? Yes, we can do that with the help of this MCS. So what is this MCS does is, if you have the multiple GKE clusters, it's a feature which is a very good feature of the GKE. So let's say you have around 2 to 3 GKE clusters which are part of the fleet. Then what we can do is you can deploy this service, or you can deploy an application in one cluster and you can expose it as a multi-cluster service. Then moment that is with the help of an object or with the help of a custom resource definition called as service export. So moment you expose a particular microservice as a MCS, micro multi-cluster service, so that will expose that across the fleet as a service import resources, so that the individual clusters can use that. That means moment, say for example you have a service for say service A. For that you are exporting it, creating a definition, a service export definition for that service A. So what happens is, as soon as you create that definition, which that information will be spread across the fleet, and the corresponding service import definition, definition or import object, or you can say custom resource definition, will be automatically gets created in remaining clusters. That means if it is exposed in a cluster A, that will automatically creates a service import object in cluster B and cluster C. That's how simple it is. So in the, what is the beauty of it? That it just provides you a best mechanism of defining a service in one cluster and consume it across the different cluster through cluster IP service. That means you need not to go and deploy that application in multiple environments, I mean multiple clusters, since it's a part of the same fleet. That's the beauty of fleet. I mean, like, you just define it, that spread across, the information is spread across the fleet, and that automatically ensures that that corresponding import definition is placed on different clusters and that can be consumed. So let's go to one particular example. So if you come down here under the multi cloud load balancing, that I have already opened in another session, this another tab, sorry, this is like deploying multi-cluster gateway here. So there you have couple of architecture diagrams where one can easily understand these things in detail. So let's take the first example of this multi-cluster service. So let's come to this diagram. So if you see here, that we have two Kubernetes clusters here, GK West one, where, which is as the name suggests, it's created in the region US West 1. Similarly, the GK East 2 it's created on US East 1. So in this case, what we have done is, again, they have same namespace. It should be. So it's like a store namespace. The store pod, which is currently running in the West 1 cluster. So what we are doing here is we are creating a service and then the corresponding service export definition here as well. So this is, I mean, we have deployed a service, I mean, the store microservice deployment. So once that is done, I'm exposing it, like if you see here, I'm referencing the deployment here through selector, and that I am exposing with the port 880, the corresponding service export definition. So this is the template for that. So where you are mentioning the API definition for that and the corresponding namespace and the name of the service. That's simple it is, that's straightforward. So the moment you do that, so what happens is so as soon as the service export and the service pair of definitions are written, so what it does at the fleet level is it ensures that it creates a service import definition in all other remaining clusters. In this case, we have only one cluster, which will be like GK East 1. So it will go and create that cluster in, I mean, that particular service import definition in another cluster, and that is available as a cluster IP. No, that's simple. It's straightforward. So in this case, we have just one cluster. If there are around 3 to 4 clusters which are part of the same fleet, it ensures that that import definition is there in all remaining clusters as well. And that is again via cluster IP. So as soon as, I mean, this would take approximately from, a couple of seconds to maximum up to 5 minutes. You can say in some scenarios, I saw it provisioned within a minute. Sometimes it took up to 3, 4 minutes or some, up to 5 minutes as well. So it depends, there could be a lot of factors in happening in the behind the doors which we don't know because that is something which Google manages. But on an average, from the couple of seconds to maximum 5 minutes duration it may take to provision this service import definition in the individual clusters. That's it. That's the stuff about MCS. Now let's come to you know the multi-cluster gateway. I mean, again, if you want to reference this for across the application via HTTP route, you can always go back and do this. So that's the another, beauty about this. With this explanation and all, I have, I'm planning to create a separate video where, I'll be provisioning around 3 different Kubernetes cluster. One will be my config cluster where I'll be enabling the multi-cluster gateway, and then, and 2 remaining clusters like cluster B and cluster C where the application workload will be running, and with the help of this MCS and MCG, how we can set up and how we can handle everything. I'll be demonstrating in the upcoming video. Don't worry about that. So let's come back to the multi-cluster gateway. So what happens here? So in this case as well, the same approach. You have one cluster which is dedicated for again. This is just an working example, or you can say a reference architecture. It need not to be that you can have a dedicated cluster to maintain the configuration. There would be some kind of in cost constraint or some other challenges in terms of the resource limits and all. So always you can like you can leverage all these configs within the one GK East 1 itself, and you can consume you can use this cluster for workload as well. So it's up to individuals how they want to. If they have leverage to maintain all these things with the cost freeness and all, they can. But again, it's the individuals who has to take that decision. So in this example, if you see, we have a dedicated Kubernetes cluster. Okay, let's assume it is running on US Central, and then we have two, Kubernetes cluster, one running in West 1 and one running in East 1, where actually our workloads are running. So again, we have taken a store example. So now what is happening here is we have deployed the same store application in GK West 1 and same store application GK East 1. So now, what is happening is I have already shown you the how we can create a service and export it. So in this case, so we have let's come to the gateway. Before that, I'm just giving you the explanation like what we have deployed here. So we have deployed the service. I mean the store service here, and then the corresponding service export. That means this can be imported in the remaining clusters which are part of this fleet. In this case, just the east one is there, so that means these automatically creates a service import in the GK east one. Similarly, the service which are running here, which I'll give the different name. For example, here the service name I'll give as service west one. Similarly, service export west 1, so the corresponding service import east 1 will be created in the east 1 cluster. Similarly, here the service east 1 which I am creating here, will the service import definition will be created in the west 1. That means extreme high availability, we can say. It's like even for service export import as well, the high availability. So now what happens is, in the config cluster, the main Kubernetes cluster, I will be enable when I create a Kubernetes cluster, I will be enabling something called as a gateway API, which I'm going to show you in the upcoming session. Don't worry about that, like how to enable the I think I have already shown in the previous video. Yeah, I think I have already shown you in the previous video where how to create a gateway API. I mean, how to enable the gateway API and how we can leverage. Yeah, I think I already shown you. So that gateway API you are enabling, moment you enable a gateway API, that's a cluster which is eligible for a gateway handling the gateway controllers and all those things, to creating the gateway classes. And at this moment still it is a single cluster gateway. You are still not enabled a multi-cluster gateway, so that feature you are enabling with the help of an ingress define ingress feature enabled at the fleet level. Moment you enable, then that will become a multi-cluster gateway. That means it additionally provision few more gateway classes. Again, how to do it and all we will see in the next session. For the time being, so when you enable, just remember that when you enable just gateway API, it is enabling a single cluster gateway. The moment you enable a definition, G Cloud container fleet ingress, and then the complete the definition of that. Moment you enable that, then it that cluster is eligible, gets the eligibility as that multi-cluster gateway. So when you enable the multi-cluster gateway, automatically you would be getting the multi-cluster gateway controllers as well. So that's the beauty. So about like single cluster gateway controller, multi-cluster gateway controller, I have already discussed in my previous video. Means basically what kind of load balancer you would be able to provision and all those things. So that's simple. So what is happening is now even in this cluster, even though it is a conflict cluster, still the service import definition, service exports which are defined in east one can also be consumed here. I mean automatically the import definition. For example, here the service export east one will create a service import east one. Similarly, here the service export west one will create a service import service east, service west one import. How simple it is, like extreme high availability. So as soon as you use the multi-cluster gateway, it would be provisioning a load balancer. So the customer or the individual user who is entering this traffic will have extreme high availability that passes through. Again, this provides the flexibility for you to even do the traffic splitting. The percentage share, like how much the individual cluster can get. All those features you can leverage. So that's about the MCS and MCG at the high level. You have your service mesh, which is almost doing the same thing. Again, in the conclusion video, let's talk about these different features and what is best. I think the individuals has to choose according to their organization needs and according to their implementations and all. But as a whole, what it can bring to the table, that is what we have discussed. So thank you, folks. See you in the next video.